Okay, we're here to look at systems of equations and how to determine the best method to use for any given situation. The first situation is graphing. So when we're graphing lines, the easiest way is for the lines to be in slope-intercept form. We've learned several other ways to graph lines, but most often the students prefer the slope-intercept form so they can graph their y-intercept and then count their slope to find another point. So if you have a system of equations in which both of your equations are solved for y, this is a good choice to start by graphing. And graphing isn't always going to work perfectly for you because if the solution isn't an integer value, it's going to be very difficult to see on the graph. So if we can use a graphing calculator, we could find the exact answer if the values aren't integers. But we also may have to resort to another method if we don't get sort of nice solutions from our graph. So here's an example of a solution that we could solve by graphing. Again, you've got your both equations in slope-intercept form. The next solution, the next method is to solve by substitution. Substitution is an important method. It's used a lot in Algebra 2, and we'll need it if we have a system of more than two equations. So when looking at a substitution problem, we want to find usually one variable by itself. So looking at this equation, this equation, or this system of equations, is set up nicely for substitution because we have one of the variables isolated, y equals. So I can take that y equals and look at my second equation and do a substitution. Replace the value y with its equivalent form 5x minus 17. That would give us a system of one equation and one variable that we could solve and then go back to get our y at the end. And the third method is elimination. Elimination is a method that's used well, or works well, if you have both equations in standard form, meaning that your variables are lined up vertically. So you have your x terms, your y terms, your equal signs, and then your constants on the right-hand side. In an ideal situation, one of these constants would go to 0, eliminating either the x or the y. In some situations, you have to do a little bit more work to make that happen. So here's an example of a system that would lend itself towards elimination. 5x plus 7y equals 2, and negative 2x plus 7y equals 9. Again, because the x's are lined up, y's are lined up, and your constants are lined up, this is an opportunity to use that elimination method. Now, it's not a perfect example because if we just combine these two, I get 3x, 14y, and 11. So sometimes you have to do a little bit of manipulation. In this case, I want the 7 to be negative. So of course, if I multiply this whole equation by -1, or think of subtracting this equation, that's how we're going to get this y value to eliminate. Okay, just real quick, we'll go through a couple of examples and what would work well and what doesn't work well for these problems. So for this first one, again, they're lined up vertically. That looks like a good problem set up in standard form for elimination. In this equation, you have both, in the system, you have both equations solved for y. They're in that y equals mx plus b. It looks like graphing would be a good place to start. It's actually a special case there where you're going to have parallel lines. This problem you could do by graphing or substitution, but since we already have half of our answer, we already know the x, really all we need to do is substitute that value in to get our y. So I would use substitution. And let's go over here. Two equations in y equals mx plus b, that would be a good graphing method. Again, lined up vertically. Looks like a good elimination problem. And this last one we're going to look at is solve for y, so this looks like a good substitution problem. It's important for the students to have knowledge of all three methods because there's situations where you're going to think, oh, I'll use graphing for this method, and it doesn't yield a solution that's easy to see, so you have to fall back on substitution. All right, hope that helped. Thanks for listening.